Welcome to Power Supply Review Half-Wave Filtered Rectifier. All right, so here is our schematic. We've got our transformer, our single diode for the half-wave rectification, our capacitor for the filtering, and a resistor for the load. So the first thing we need to do is determine the primary voltage. That would be what's across here from pins 1 to 2. And if that voltage is given in RMS, we'd want to convert that to a peak voltage. And then once we've got the peak voltage, we can use the turns ratio of the transformer to determine the secondary voltage. Now that we have the secondary peak voltage, we can subtract the diode voltage, the 0.7 volts for the diode, and that will give us what the maximum voltage that capacitor is going to charge to. And we know that that is actually going to be our Vout max. The next thing to do after we've got our Vout max is find our Vout min. And what that is going to be is the capacitor voltage is going to discharge during the period where the diode is reverse bias, and we're going to use that formula VC equals V final minus quantity V final minus V initial e to the negative time over tau. And because this is, we're using it in terms of a discharge, where our V final is actually 0, where our V initial is going to be what our VC max was. And the discharge time for the half-wave rectifier, we'll need to find the time, which is going to be 1 divided by the frequency. And for the half-wave rectifier, the frequency is going to be 60 Hertz. All right, so now that you've got V max and V min, you can find V ripple peak to peak by subtracting V min from V max. You can find the VDC, which is the average of those two voltages. So we're going to add Vmax to Vmin and then divide that by 2. We can then calculate the RMS voltage. We've got ripple peak to peak divided by 2 times the square root of 3. And our percent ripple is calculated by dividing the VRMS divided by VDC and then multiplying that by 100.